I'm going to discuss about the last category of shift register, that is parallel in serial out shift register. So before that, in my previous lectures, I discussed about the remaining three categories, that is serial in serial out or CISO. Okay. Then I discussed about serial in parallel out or SIPO. And I also discussed about parallel in parallel out PIPO. So these three things I discussed in my previous lecture. Now in this lecture, I'm going to cover the last category, that is parallel in serial out. So in this case, you have to remember or you have to understand one thing. This parallel in means you need to give the input parallelly or simultaneously in x0, x1, x2 in x and in x3 terminals. Okay, for this particular configuration, you have 4 input terminals, so you need to parallelly apply the inputs. Okay, or simultaneously you have to apply the input. After applying the input, you need to shift these values from first stage to second flip flop, second to third, third to fourth flip flop. You need to shift that value. So ultimately, what I am trying to say here, you are two operations. One is parallel input you are giving or parallel in operation you are doing. And in the second stage, you are doing serial out operation. And both you cannot do simultaneously. First, you need to do parallel in because you need to input the data. And after that, whatever data you have inputted from there, you need to serially transfer those data. Okay, and you will get the output serially from this terminal. Okay. In order to do this work, you have given a common input terminal, that is shift/load. Shift/load bar input. This particular input I'm talking about. You need to use this input. So if you give this input as 0, it will do the load operation. And if you give this input as 1, it will do the shift operation. So load operation is nothing but you are giving the input or parallel input operation. Okay. And shift operation is nothing but serially you are getting the output. Okay. So first of all, you need to do the load operation. Load operation means what I told you need to give 0 here in this particular terminal. So if you give 0 here, what will be the output from this AND gate? This is 1. Sorry, from this NOT gate, what will be the output? This is 1. So 1 means this terminal is 1. This terminal is 1. This particular terminal. This particular terminal is 1. This particular terminal is 1. So what I am trying to say, one of the input of this G1 gate, G2 gate, G3 gate, and G4 gate will be 1. And what is the category of this gate? This is nothing but AND gate. So in AND gate, if one of the input is 1, whatever input you will apply in the remaining terminal, that only you are going to get from the output. This is the principle of AND gate. So as your one of the input is 1, when you are applying 0 in the shift/load terminal, so it means that the G1 gate, one of the input is 1. In G2 also one of the input is 1. In G3 also one of the input 1. And G4 also one of the input is 1. So ultimately what it indicates, what input you will give to the other terminal, that only you are going to get from these gates. So it means what input you are giving in X0 that you will be getting in the output of this G1. What input you are giving in X1 that you are getting in the output of G2, or what you are giving in X2 that you are getting in the output of G3, what you are giving in X3 that you are going to get in the output of G4. Okay. And that is only we want in case of parallel input. We need to input the data parallelly. Now, if you can see, what about the other gate, other AND gate? That is at that time, what G5 and G6 and G7 are doing? Because if you see, when you have applied 0 here, it is 0. Okay, so this terminal is connected to G5, G6 and G7. So what does it mean? In AND gate, you have connected one of the input is 0. So what the output will be? Whatever may be the remaining input, your output will be always 0. This is the principle of AND gate. So as you know, in this case, your G5, G6 and G7, which I shown by the red color, it is connected. One of the terminal of these gates are connected to 0. It means whatever may be the remaining input, its output will be always 0. In this particular case, when your load slash means shift slash load bar is connected to 0. Okay, so what does it mean? When you are giving the input parallelly, at that time G5 output, G6 output or G7 outputs are 0 only. This is the meaning of this one. So ultimately what it indicates? It indicates at that time what input you have given in X1, that is coming only from this OR gate, because this is 0. This G5 output is 0. It means that what output you are getting from G2, that is only you are getting from this OR gate. Okay. And similarly, same thing is applicable for the second one also. What input you have given in X2, that is only you are getting from the output of this gate. And what input you have given in X3, that only you are getting from the output of this OR gate. Okay. And here X0, what you are giving, that is only you are getting. So ultimately what I am trying to say, when you are giving this 0 in this shift slash load bar terminal, at that time, what input you are giving parallelly, that only coming to the input of each of the flip-flop. So means X0 is coming in D0, X1 is coming in D1, X2 is coming in D2, X3 is coming in D3. Okay, so this is the parallel input operation. After that, what you need to do, you have to do the serial output operation. So how to do? So in the second stage, what you need to do is, in the second stage, what you need to do is your load bar slash shift input you need to consider as 1 for the second stage or serial output stage. What you need to do? You have to use this particular thing, means this terminal now has to be connected to 1, means you have to use this particular input. Okay. Now, in this case, we are doing the second operation, that is serial out operation we are doing. Now we'll check how we'll do the serial output operation. Now, when you are giving 1 here, what does it mean? This output of this NOT gate, it becomes 0, because as it is 1, the output of NOT gate, it is 0. So it means that this terminal is 0, this is 0, this is 0, this is 0. So ultimately what it indicates? The output of G2 0, the output of G3 0, the output of G4 0. Okay. So what does it mean? It means that only this terminal is working, means this time only. It means that this time only, at that case, your G5 is working, G6 is working, G7 is working. How I am saying? Because see, this is connected to 1. So one of the terminal of G5, G6 and G7 is connected to 1. So whatever the input will be there in the other terminal of these gates, that will be the output of this OR gate. This is the meaning of this one. Understood? Because when we are applying 1, in that case, your these gates are deactivated or this becomes 0, means G2 deactivated or this is becoming 0, G3 0, G4 output is 0. Okay, so in one case only G1 output can be working, or means sorry, not G1, actually G5 or G6 or G7. Okay. Okay, so when you are applying 1 here, only G5, G6 and G7 is working, because one of the input of these gates are connected to 1. So what will be the other input? That will be the output of these gates, and that will by default come in the output of this OR gate. So here also coming to the output of the OR gate, here also it is coming to the output of the OR gate. So now what we are doing? So it means that we are doing the shifting operation. You can see here, this is the path only we are following when we are considering this input as well. So how we are doing the shift operation? What input we are having in the previous stage? That is X0, X1, X2, X3. Accordingly, we are getting the output. So if we apply the first clock in this serial output state, Whatever x0 we are having, that will be getting here. What x1 we are having, that will be getting here. What x2 we are having, that will be getting here. What x3 we are having, that we are getting here. So after the first clock, we'll get the x3. Okay. It means this LSB bit will get in the serial output after the first clock. Now, if we apply the second clock, what will happen? The second bit means x2 will be propagated to the next stage and corresponding output I will get here. Okay. Now, if I apply the third clock, what will happen? This third stage will be propagated from here to here and I will get the output of x1. Now, if we apply the fourth clock, what will happen? This x0 will be propagated from here to here and that will come here. This x0 will come. So it means if you want to get the entire bit combination, you need to use at least 4 clock. Then only the entire thing you will get. So from x3 to x0. Because if you can remember, when I told you are getting x0 after applying the fourth clock. Okay. And how this is this transfer is done, that is just the principle of your serial in serial output only. If you just understand this one, you can easily understand how this transfer is going on. Okay, so I will suggest you can go through the video of serial in serial output that I uploaded. Maybe my third or second video, what I uploaded, that will cover this portion. And by covering that thing, you can easily understand this particular thing. Okay, so ultimately, briefly, what we can tell, if you have 4 bits and if you are applying in the input parallelly, after applying 4th clock only, you will be getting this output serially from parallel in serial out shift register. So you have to use at least 4 clock to get the entire bit combination in the output. Okay. So if you have n number of bits in the input, then you need to use n clock to get all the bits serially in the output. Okay. So this is the principle of parallel in serial out shift register. Thank you.